know what they've blocked. I mean, it's not a matter of opinion. They know what they have blocked, and so they should be able to come back to me and say, we've blocked these features. Oh, okay, well, thanks for telling me. Now I know.
Well, I don't think it's anything they blocked. I think it's just the way YouTube works. I think it's YouTube itself, maybe not necessarily.
No, that doesn't make sense, because why can you watch it on your phone but not your Chromebook?
Because my account on my phone is set to over 18. Because a lot of YouTube videos are.
That doesn't make, yeah, but that doesn't make sense either, because there's no YouTube policy. If you're under 18, that means you can't watch anything that's not specifically made for kids. No, I don't think that. I don't.
Restricted videos, which means you just have to be over 18. And I'm assuming they have live streams also in that, because the chat could be.
Maybe we'll have to see. Anyway, let's continue with this discussion and not that discussion, and we'll do what we have to do. Okay. Next question. We have plugged this in. What else could we plug into that equation? What else could I plug in right now? Brooke. Nothing? You don't see anything?
We already got the vertex.
Yeah.
Maybe something in A, but I'm not sure.
Do we know A?
Possibly. I'm honestly just kind of guessing.
Yeah. Let's not guess, because we'll get there. But I'd say we don't know what A is. In fact, if A were 3, doesn't a quick graph mean that if this is for A were 3, then actually this would have a point here, would it not?
4, not 3.
So
we don't know.
If A were 4, then we'd have a point down here. See, I mean, we could guess away at what A might be, but I would say that that's not a good strategy at this point, because we don't really know. And now we're just guessing and checking. And do you know what I hate more than almost anything in the world? Guess and check. Here, we'll list this under things I hate. It's inefficient. So what else? What else could I put into that equation? I have y equals a parentheses x minus 0 squared plus 3. Let me say it again. Y equals a parentheses x minus 0 squared plus 3. Nothing? Nothing popping? Nothing's registering? Y equals a parentheses x minus 0 squared plus 3. Can somebody tell me something about that pair of numbers right there? What are they? They're x and y. Or y and an x. Yes, they are the x-intercept. Yes, they're a pair of numbers, but specifically, they represent a value of x and a value of y that go together on the graph. And this is something that we forget because we get so used to looking at these things. And when we see 4, 0, we just go 4, 0, but we put a dot. Negative 4, 0, negative 4, 0, put a dot. 0, 3, 0, 3, put a dot. And we forget to think to ourselves every time we see them, oh, when x is 4, y is equal to 0. So I will go 4 in the x direction and I will go 0 in the y direction and I will put a dot, because it just becomes completely automatic. We don't have to think about it, right? But that is a value of x that goes with this value of y. So would it be fair to write that 0 is equal to a times 4 minus 0 squared plus 3? Is that a true statement? Yeah, because 4, 0 is on this graph. It is a value of x and y that makes this equation true. Can I? calculate A? Yeah, one unknown. Go. Calculate A. Henry, what do I do?
I have no idea. I was just trying to figure that out myself.
Nothing? Nothing you could tell me that would I could simplify or nothing.
Oh, well, I was going to square 4 and then add 3 to that, and I know that 0 is equal to something times 7. So,
Wait, you were gonna square 4 and add 3 and somehow get 7?
or no, so yeah, never mind. I lost my track of thought while I was saying that. Sorry.
Give me something. Do one thing. Don't do a whole bunch of things. Do one thing.
Okay. Well, 4 squared is 16.
Okay, 0 equals something times 16 plus 3.
Isn't 0 equals 0, Mr. Armory?
That's hilarious.
Well, isn't that
Hi, Mr. Donahue. So I got a question. Is the next step to add 16 and 3? Why not?
You have to divide by A.
Oh, so I'm going to divide everything by A? Okay, let's do it. That divided by A, and this divided by A, and this divided by A, until my new equation, what's 0 divided by A? Well, of course we know. Yeah.
divide by 16, right?
Well, no, he said divide by A. We're dividing by A. What's 0 divided by A?
0.
0 equals, and then that reduces 16 plus 3 divided by A. I'm okay with it. I mean, I'm not thinking it's any easier to solve now. So let's go back. Let's go back to not divided by A. We can't add the 16 and the 3. Can't divide by A. By the way, we didn't actually get an answer as to why we can't add the 16 and the 3. We just went straight to let's divide by A instead. Tyler?
Order of operations, there's multiple first.
Yeah, you have to multiply that before you can add that. Yeah.
Wouldn't you?
Well, oh, sorry. Go ahead.
Oh, sorry, I thought you.
No, I was stumbling over names
Okay.
because Tyler and Terrell are sitting right in front of each other, and so then it was like, oh shoot, which name do I say? Go.
You divide by 16, and then you still get 0 because anything with 0 in the numerator is 0. So you have 0 equals A plus 6 or 3 over 16.
Now what?
Subtract 360. And then you get A equals negative 360.
That may have been the most painful thing we've ever done in this class. Guys, this is a 2-step equation. You learned how to do those in the 5th grade. I can't believe it took us like 7.5 minutes to solve a 2-step equation. Can I suggest something even easier? subtract the 3, because then you don't have to deal with the 0 anymore, and you get negative 3 equals a times 16, and then we divide by 16. And it works out to be the same thing, but if you divide first, you have to divide 3 things, even though one of them ends up being 0. It's just inefficient. It's a step that you don't need to take. So let's go back to where we started, which is right here. We know that h is 0, we know that k is 3, and we now know that a is negative 3/16. And we don't have to necessarily write the 0. We could just write x squared. I write it as x minus 0 just because, I don't know, it tells me that the vertex is 0, 3. Guys, are we comfortable with the fact that we probably would not have come up with a stretch factor by guess and check? It becomes a difficult, it's a difficult stretch factor. And the more complicated the problem, the harder it is going to be to guess and check the stretch factor. But what we know is that we've got the vertex and we have a point, which is to the single unknown. Tyler.
Wouldn't it, because it's a negative 3/16, would the entire thing be opening down, so it wouldn't be? Oh, I'm stupid. Never mind. Sorry. I had to look at that for a second.
You're not
Oh,
stupid,
man.
but yes. But yes, you're right. It's opening down. Yeah.
Okay.
All right. Cool. Any questions? Problem number 2. Your turn. Here's the scenario.
I had to go sit to my face right now. I look like a tomato.
What? Well, don't worry about it. Don't worry about it. Guys, here's the scenario. Mr. Everding has a degree in aerospace engineering because he loves rockets. He thinks they're cool. So, here's a rocket. You launch it. When you launch it, flames and smoke all come out. And because it's a parabola, it's going to crash is not actually a true statement, because what you can do is you can launch your rocket, and then when it gets to a certain point in the parabola, you kick on a booster motor that then kicks it into a Earth orbit. So it doesn't have to crash. You put in a second motor to keep it going. However, in this case, this is a model rocket, and it does crash because that's what you do. You shoot it up in the air. Actually, what you normally do on these things, we used to play with them when I was a kid. They actually had a chemical motor and a little launcher thing, and you'd wires, and you'd stand off, and you'd push the button, and it would launch it. Also had a parachute. At the end of the motor, there was a little explosive charge that would pop it into 2 pieces, and their parachute would pop out, and then the 2 pieces would be hanging under the parachute, and it would come down. But we're going to ignore the parachute part, because what we want is we want to just kick it off the ground and have it land on the ground somewhere. Here's what we know about the rocket. It lands 1,500 yards away, and it reaches a maximum height of 1,200 yards. And it travels, of course, in a parabola. Cohen.
What about Air Force and aerodynamics?
Say again?
What about Air Force and aerodynamics?
Doesn't matter. No, I'm serious, it doesn't. It's completely irrelevant because it will travel in a parabolic shape. Once the motor shuts off, that rocket travels in a parabolic shape. Now, where all this stuff you're asking about comes into play actually has more to do with when you are trying to power the rocket, if you're trying to steer the rocket, if it's a plane instead of a rocket. But for a fairly reasonable first order approximation, once it's not being powered anymore, it's going in a parabola until something stops it. Okay? So here's what I want you to do. I want you to find the equation of this rocket in vertex form. You have all the information you need.
Are we saying the x-axis is just through the middle?
Good question. Can you put it anywhere you want since it's your problem? No, that's a legitimate question, and that's a serious answer. You can put the axes anywhere you want. It's your problem. Now, you better be darn clear on where your axes are if you come up with something weird. Because if somebody looks at your weird thing and it turns out that you've made some odd choice for your axes, it just makes life harder for everybody. So I would pick something sensible. What do I mean by what?
Odd.
I mean, if you said I'm going to have my rocket take off from 10,000 yards and 8,000 yards way up here, why would you? Why would you set your axes in a strange place?
Hey guys, this is opening down too.
There's nothing wrong with doing that. I'm just saying that my numbers are 800, but remember when you write your final equation, you're going to have to go back and write the numbers. Otherwise, you potentially could, you'd have a problem that you have to be very, very clear that everything's in hundreds instead of an actual number. Wait, what? Why did you get a 1 and 1499? Yeah, but where did it start? So you started it at -1? Why?
It's the first X intersection.
Why?
To make it easier.
Does it make it easier?
Yeah,
What if you
square.
made that 0? Then what would this be?
Yeah, that would work too.
Oh, okay.
It's
Just
not
checking.
working.
Just checking. So let's see. Oh. that really your vertex? You have the vertex on the ground. No, you don't, you have the vertex on the y-axis.
Oh, right, that's, okay,
Yeah.
that's why I can do it.
Yeah.
Okay, I was gonna say, it seemed too easy, I was like.
You might want to be your parentheses. 750 squared. Three numbers. Of course, if you knew your 75 times tables, it would be easy. You're not gonna read decimal there. I hope not. Right off the bat, I see, we usually see for easy simplification. Hey, guess what's divisible by 3? 225.
That's very good.
You know how I know that? 2 plus 2 plus 5 is 9.
That's true. I do remember that.
What?
That's the reason why.
Well, you still got the vertex in the same place.
Oh, well, yeah, I meant the equation, it's just hard to say.
So your vertex is, yeah, but, so, yeah, because here,
I never mind. I know, I just now realized what I did,
yeah,
because it would be minus 0.
yeah, exactly,
Yeah,
exactly.
which is it.
And here's the problem here, where's your vertex gonna be with those two numbers you chose? I feel like it would be really? If you add those together and divide by 2, okay, yep, I'll buy that. So that has to be 749, and this is unknown.
Right.
Because that was the other thing again, you had to, I feel like you had.
Oh, this is my last equation.
Oh,
I just
gotcha,
showed you, yeah.
okay.
So that's- yeah.
Yeah,
This is right.
I don't know, does it work?
Yeah.
That must be right. That's the beauty of math. Yeah.
Okay. At least I got the negative part.
I'm not sure about the 1875, but I'll believe you.
I'm gonna check it again.
Okay. 1 carried to 2, 8 carried to 2, 7 carried 1, 5. Yeah. But really, the best way to know if it's right would be to plug it into your calculator and see if it gives you all those points. No. 1/46,875? No.
Wait.
How do you get a, yeah,
I think
I'll buy this.
I did that. There's no 2 zeros, just 1 thing.
Oh, yes, correct, yep. All right. Question number 1, Cohen. Where'd you put your axes?
X equals 0, or.
So where does it launch from? Maybe is a better way to ask the question.
Yeah,
Give-
launches from negative 750.
Where does it land?
750.
What's the vertex?
1200 or 0, 1200.
Is that okay? I'm fine with that. I'm fine with that. There's nothing wrong with that. Because you get to set your axes anywhere you want. And I would recommend something convenient. One option I saw that I wasn't totally thrilled with, but it works, was launch it from -1 and have it land at 1499. And then the vertex was at 748, 1200. I feel like what you're really doing is making your life difficult. For one thing, it was harder to figure out the vertex because you had to actually figure it out instead of just going, oh, look, half of 1500 is 750. You had to think about the difference between -1 and 1499, which you know is 750, and then blah, blah, blah. Oh, it's 49. Yeah, sorry. And there's that. Third possibility, where could you launch from? Guys, the normal choice for this kind of problem is going to be, let's launch from 0 and see where we land. And the reason it is going to be the normal choice is because when you're starting a problem, you don't know where it's going to land. Which means that you can't do anything until after you've got all your data in. If I just say I'm going to launch from 0, I could draw a graph and put a dot at 0, and then I could launch. And then when the guy runs out with his tape measure and he says 1,500 yards, you put another dot and you say, okay, there we go, it landed. And then the other guy's got his little inclinometer thing going and he says, top that at 1,200. Boom, I know where that point goes. Here's another thing to think about when you're doing a problem like this. I build my rocket and I launch it. And it does that. And then you guys are each building your own rockets and you're launching them. And somebody's rocket goes like that, and somebody else's rocket goes like this. How do I do that on this graph? You see the problem? If the competition is whose rocket goes the furthest, it's really easy to tell that this person won the competition. If the competition is who went the highest, it's really easy to tell. But if you look at this graph, yeah, highest is easy because they're all on the y-axis, but when you're graphing the other graphs, it's sort of like, well, there's one of them, but then after the fact, I have to go back and I have to calculate how far they went, and I divide that in half, and now I've got another graph that goes like this, and then I've got a third graph that goes like that. And it's sort of an odd way to set it up. If you said, hey, let's all go out and have a competition kicking a soccer ball, we wouldn't each kick the soccer ball, and then you would find out how far they all went, and then you would draw a graph where the axis was right smack in the middle of everybody's soccer ball. You would line everybody up at the same place, and you'd all kick the soccer ball. So when you graphed it, they were all starting from the same place. So for a variety of reasons, this makes a lot more sense than any other options. It doesn't make any of them wrong. There is no wrong answer to where do you set your axes. But there are easier and more useful answers to the question, where should I set my axes? And generally the answer is set it at 0, okay? You will get a different equation depending on where you set your axes. So you could theoretically all have different equations and you could all be right. Now here's the thing. You need to be very clear about what you did when you write down your equation. Your answer needs to have a picture of the graph along with an equation. Because if you just write down an equation, it doesn't mean anything. If you wrote down the equation for that graph, but it had this picture, it would be wrong. So if you wrote down the equation for this graph and don't have a picture, how's anybody supposed to know what you're talking about? See the problem there? So you got to go have two things. You need to have a picture of a graph And you need to have an equation that says this is the equation for that graph. All right? So let's, what was our stretch factor? Anybody?
-4/25.
I'm gonna completely disagree. Tyler?
I got -4/1875.
Did you square that value, Cohen, before you divided?
Maybe not.
I think that's probably where that went, is that you forgot to square that before you divided both sides. Did anybody have a decimal stretch factor?
But you don't want decimals.
You're darn right I didn't. I just wanted to see if anybody would fess up to, yeah, I did it, even though you told me not to. What is 4/1875 as a decimal? If I remember correctly, it's 0.002133333. Is that, can
Yeah,
somebody,
That's
can,
correct.
yeah? Yeah. I'm, wait, you can't do that in your head?
No.
What the heck's wrong with you guys? I didn't do it in my head. We just had the same discussion on Tuesday, and one thing I am very, very good at is remembering numbers. But here's the problem with that. How accurate is this?
Not accurate.
It's accurate to 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. They're reasonably accurate, but it's only 9 decimal places. What if I need more accuracy? How accurate is this?
100%.
100% accurate.
What if you drew the line over the 3? Wouldn't that make it accurate?
Is that true? How do you know?
What if it was the
I
2?
don't know.
How do you know what, do you know what the next decimal is? Did your calculator tell you the next decimal?
Is it repeating means thing?
How do you know it's repeating? Just because you're saying there's, well,
Oh,
no. You don't get to do circular reasoning. I'll draw a line over it, and then when someone says, how do you know it's repeating? You say, because there's a line over it. Yeah, but you drew the line. No. Guys, in all seriousness, how do you know that this repeats?
Well, we don't.
You have no idea what the next decimal is, because the next decimal could be anything under 5. Agreed? It could be 4, 3, 2, 1, or 0, and your calculator will tell you it's a 3. We have no idea what comes next. And if you just put there are 4 3s, so I'm sure there are an infinite number of 3s. That's awkward. And that's a real answer. Again, I'm not messing. I will mess with you guys on occasion. Believe me, I'm gonna mess with you. I'm going to say things that you're going to be like, wait a second, that can't be true. But in this case, you don't know. And so it's not legitimate to just make an assumption and slap on a bar. It's also not useful to slap on a bar, because then how do you type that equation into your calculator? There's no repeats forever button in your calculator. So if you want to actually use this equation and you type in y equals some number of decimals, you've just said, I don't care about exact answers. I'm going to get an approximate answer. Now, it might be a very good approximation if it's 9 decimals. It might be. It also might be a horrible approximation. Depends on what you're doing. Depends on what you need. And when will you find out whether it was a good approximation or a bad approximation? When your space shuttle blows up, killing everybody on board. Oh, we shouldn't have rounded. Darn it. I hate when that happens. What's that?
It was just a model.
Rocket
Well, why are you shooting off model rockets?
for science class.
You're shooting off model rockets so that you can gather data for designing. You don't think they shoot off model shuttles, full-size model shuttles with crew, No, you do the calculations. You calculate ahead of time. You test your calculations. You test them with models. You test, and then you build a full-size space shuttle. And when it blows up and they come to you and they say, hey, why did the space shuttle blow up? And you say, oh, I thought that 3 went on forever. Well, that's awkward. Didn't Miss Armoring tell you about that in high school? Yeah, but I ignored him. Oh, bad planning. All right, so the equation is going to vary depending on your axes. This will not. So Cohen should have had y equals -4 over 1875 x squared plus 1200. And Ryan should have had y equals -4 over 1875 x minus 749 squared plus 1200. And this graph should have had y equals -4 over 1875 x minus 750 squared plus 1200. Notice that the vertex changes, but nothing else does, because the stretch factor sets the shape of the parabola. And since all these parabolas have the same shape, all we're doing is setting our vertex differently by choosing different axes. Doesn't matter, doesn't make any difference. All right? You guys cool with this? If you go into Google Classroom, there is a classwork worksheet, and it is called Classwork Modeling Quadratics, probably. I honestly am not 100%.
Say modeling extra practice?
Does it say modeling extra practice?
I see that.
That's the only one in there.
Okay, so, but it says modeling, right?
Yes.
Guys, there are 2 problems. There is a soccer ball problem, and there is a skateboarding problem. I want you to do those 2 problems. You can do them in your Chromebook. Guys, is everybody able to open things in Canvas? You're,
I just use .com still.
okay.
Yeah.
So, guys, since we're here, I'm going to start to walk through this with people. Here's the easy way to get to Canvas, which is apparently even easier than using the app. You can just open the browser window and type in Chrome Canvas in the browser window. All the process is the same, I guess. But it's right there. It'll open in the browser. It is such a much better program, and honestly, the problem is that I have to grade everything that you guys turn in, and DocHub is so horrendous that I have to sit there and stare at people's assignments and try to decide whether they knew what they were doing. And the problem is not that they didn't know what they were doing. The problem was that DocHub won't let you accurately write things or neatly write things. And so then I sit there and I go, well, okay, maybe yes, maybe, So I would much prefer if your Chromebook will do it. We're starting to run into the problem that a few of them are quitting using Canvas, and we don't know why. But if you can access Canvas, I would much prefer that you do that.
Mine stopped using Canvas.
They give you the little square sad face.
Yeah.
Yeah.
Is it the app or do you use the browser?
Folder. And then I could edit.
Yeah. So let's do this. Let's experiment with some things. Let me borrow this for a second. So I'm just, I've read somewhere that maybe the problem was with the cache. Okay, so no. Do you shut this down or just close the lid when you're done?
Just close it.
If we restart it and maybe something resets itself. I'm not taking it down because
No, that's fine.
okay. Now.
Just do it on paper. And it's fine.
No, and that's fine. That's fine. It was just, I mean, the whole point of having tens of thousands of dollars of Chromebooks available for everybody in the district is so that we have Chromebooks that we can use for all sorts of cool things. Yeah.
So when you're in downloads, it doesn't actually show up in here.
You gotta press control of
Control what?
while you're on.
Well, let's go back. Go back to where you downloaded, which would have been what? Oh. Open the file browser. That files.
Because in the file browser, it shows it. But when I try to open through,
Oh. Go back to Canvas. I know it. I know exactly what you're doing. So then this is what he was saying is you're not gonna open, you're gonna go Control and then O, which is the shortcut for opening a file, and there you just store it, yeah.
okay,
And now click on the right button up there. And now you can click on the pen, and you know that there's a thing there, right? Yeah, because you use it docked up, so. Cool. Woo. I tell you guys, that when we've been at school about 3 weeks in September, I was doing something and my pen quit working, my stylus, so I put it back into the charging port and I pulled it out so it would reset. And then I sent an email to the whole staff saying, oh, by the way, if your stylus quits working, just put it back into the charging port and then take it back out again. And I got 3 responses from teachers were like, there's a stylus?
I didn't know that either, and I was, like, the first 2 weeks, I missed the first 2 days, and I was wondering how people could write so neatly, because I was writing with my finger.
That's what you were doing?
Yeah.
Because that was really good writing for just.
Oh, no, that was like the first one, and I had like a T that was disconnected, and a Y was like over 10 feet.
That's awesome.
Mr. Rumsey,
Yes,
can I use the bathroom?
you may.
Thank you.
Nothing to do with that whole. More. All of my better.